to explore how the human mind processes learning. So we gave Dr. Brain 4 minutes. Let's see how she does. Go!
Our brains evolved to help us learn and memorize information. Like, tigers are dangerous. The best berry bush is over that hill. My sister's birthday is tomorrow. And Miranda Cosgrove's cat's name is Lucy. Hi, I'm Dr. Brain. Okay, my real name is Crystal Lewis, but I have a PhD in neuroscience, which is easier to call me Dr. Brain. So, I'm Dr. Brain! One of the best things about being human is that we're learning, adapting, and growing all the time. We can learn through a transfer of knowledge, someone telling us something. Crystal, tigers are dangerous. Cool. Or we can learn through something that we experience ourselves. But in order to learn, it's not enough to know. We also have to remember and retain that memory over time. When we learn, information and experience create new patterns and connections between the cells in our brain. These changes hold or code a representation of the information, and if it's important or novel enough, it might get stored away in our memories. The ability of our brains to adapt and change like this is called neuroplasticity. Now, I hope you all remember that our brains are made up of collections of cells called neurons that are grouped together by similar functions. And they're connected to each other by long cable-like projections called axons that transmit signals from the cell body of one neuron to the dendrites of another. Not every neuron in our brain is connected to every other one. And we say brains are changeable like plastic because, to a point, the interconnectedness between cells can change and adapt over time. Studies show that when we hold new information in short-term working memory, the prefrontal cortex activates in spurts to hold that pattern so that we can access it. Without this activity, the information we're trying to remember disappears in seconds. It's like when we try to remember someone's name that we've just met. Isn't that right, Leslie? It's Lexi. Sure. To keep the information in our head, we need to convert that information into a memory. And that happens with the help of a region in the middle of our brain with a great name, the hippocampus. No, it's not a place where a hippopotamus gets a graduate degree. It's part of your temporal lobe. Along with parts of the cerebral cortex, the hippocampus works to create declarative memories of facts and events, and also some spatial memories. Patients that have damage to the hippocampus find it difficult to remember things that happened to them recently, like what they ate for lunch, but they have no problem remembering the name of their very first pet. That's because learning and long-term memory storage happens across many different parts of our brain and involves networks of brain regions. So, engaging as many parts of the brain as possible when we learn is a good way to improve the strength of the connections we're making. For instance, parts of the brain that coordinate emotion and movement, like the amygdala and cerebellum, get involved when our memories are emotional or related to a specific behavior. And this can help us learn and remember. Like, touching a hot stove is a painful way to learn not to do that again. The neuroplasticity of our brains allows us to learn and gives us the chance to keep thinking, doing, and being better every day. By learning something new, you're actually physically changing your brain. It's like exercising, except you don't have to worry about someone's sweat on the weight machine. So, let's test your memory. What is the name of Miranda's cat? I'll wait.
Shoot.
Nope, it's not Snowball. It's Lucy.
Pay attention.